Hello everyone, today's topic is about system probability. The idea behind system probability is independence of multiple events. We need to first discuss independence and the multiplication rule. When calculating the probability of a system, we are assuming that the individual events are independent. This means that the probability of one event occurring does not affect the probability of another event occurring. We can use a real-life example to clarify this concept. For example, if you are trying to import bananas from country A and country B, then the bananas of country B are rotten. This does not affect the quality of bananas coming from country A. The quality of bananas is independent. We can mathematically state this by saying that the probability of A given B is equal to the probability of A. If this is not true, then the events are dependent. If A and B are independent, then so are the complement of A and B, the complement A and the complement of B, and the complement of A and the complement of B. Now we are going to talk about the multiplication rule. If two events A and B are independent, then we know that the intersection of A and B will be the product of the individual probabilities. This applies to the independence of multiple events. The probability of A1 intersected with A2 all the way to AN will be equal to the product of each separate probability. Here is an example of a system probability problem. We are given the probability that each component in the system will work and are asked to find the probability that the system works. The first line in this system splits into two lines, line 1 and line 2, and then comes back to one line again, line 3. Therefore, there are two paths that the system can go through. In each path, the components need to work in order for the system to work. Therefore, we can mathematically say that the probability of the system working is the probability of line 1 or line 2 working and line 3 working. First, we need to find the probability of line 1 or line 2. We can find this by using the equation probability of line 1 plus the probability of line 2 subtracted by the probability of line 1 and 2. The probability of line 1 is equal to the probability of component A and component B working. If one component in the line fails, then the entire line fails. Therefore, the probability components A and B work is 0.7 times 0.8, which is equal to 0.6. Next, we need to find the probability of line 2 working. This is just 0.8 because there is one component in the line. Using the equation from above, we can see that the probability of line 1 or line 2 is 0.92. The probability that line 3 works is 0.9. Therefore, the probability that the system works is 0.92 times 0.9, which is equal to 0.828.
In this example, the system will work if the current can make it through either line 1 or line 2, and if it can make it through either line 3 or line 4. So, we are finding the probability of the intersection of line 1 or line 2 working and either line 3 or line 4 working, expressed like this. First, we need to find the union of line 1 and line 2. So we want to do the probability of line 1 working plus the probability of line 2 working minus the probability that both are working. We subtract this because the intersection of line 1 and line 2 has been accounted for twice instead of once. Once in the probability of line 1 working and again in the probability of line 2 working. Now we need to find the probability of line 1 working. Line 1 will be the probability that A works and the probability that B works, so the intersection of A and B. We know the probability of A is 0.7, but we must find the probability of B. If we call the first component of B x and the second component of B y, we want to calculate the probability that either x or y works, so the union of x and y. We calculate this union in the same manner as above and we get 0.895. Now that we have this, we can go back and calculate the probability of line 1 working. Using the multiplication rule, we get that the probability of line 1 working is 0.6265. We now have the values to find the probability of line 1 or line 2 working using the equation we have set up above. So we get 0.96265. Now to find the probability that the second part of the system works, that is, that either line 3 or line 4 works. The probability of line 3 or 4 working is 0.96. Both the union of line 1 and line 2 and the union of line 3 and line 4 need to be successful for this entire system to work. so we use the multiplication rule. For our final answer, we get that the probability of the system working is 0.924144.